Now I want to calculate the distance between a point, which I will animate or sort of make rotate about the origin, right? So this point is orbiting about the origin, and I want to calculate the distance between this point and every single piece of my geometry, right? So that every single piece will get its distance, and based upon that distance it will influence the extrusion that is taking place onto the piece. So let's go about doing that. I'm going to turn that off, and let's turn that on and go inside. First of all, I'm going to copy a new for each of this, so just copy and paste, right? And let's create a new point that will be orbiting, around the origin. So add a new point, let's make it visible. Okay, so there's my point, there's my grid, and what I want is for it to sort of start rotating around the origin, so I can just simply add a transform and use some sine and cosine expressions to create it into a circle. So I can just translate something like sine, using floating frame, so it'll be moving. Let's increase the frequency and let's increase the amplitude. So 2.5 could be seen as the radius basically. Oops. Right, and let's do the same, but then with the cosine for the Z channel. Okay, cosine. So as I move my time slider, my point is now moving about, right? And let's make this one just visible for a second. So now you can see that the point is going through, and will, as it goes through, it will affect a fair amount of pieces. Yeah? So let's input the point into our for each. So I'm gonna input that, plug that into sort of input 3, so I'll be able to access it inside of my for each. Let's make this guy visible. Okay, so first of all, I want to get to my point a little bit easier. I know it comes from input 3, so let's just add a new null. And let's call this guy null target. Okay. Alright. So let's have a look. This little piece over there, right, I've got this small little piece. I'm going to extrude it, so I'm going to add a poly extrude to this. There. And then make that visible. I'm going to add a little bit to this, so something like 0.3 will do. So now it's got some volume, so if I just go out of it, all my pieces are now sort of, having some thickness to them, right? And already they are separated and all that, so that stays the same from the past example. We can also add a little bit of an inset to it, so that if you look at the top part, it'll kind of, go inwards. But obviously we also need to make sure that we are using the average position and not separate. So as such. So that way it'll just, extrude inwards just a little bit, something like minus 0.01, something small. And if I move up, you can kind of start to see it creates these kind of edges in between. I'll just put it on flat shaded for a second, and there we go. So you can see, the inset taking place and extrusion as well. Obviously now we need to include the distance in that. So let's go about doing that. What I want to do is I want to calculate a distance attribute. Also, one more thing before I continue with the poly extrude. The backside of this piece of geometry is not being added, so I'm just going to go to global and quickly, or rather options, and quickly output the back. Yeah? Now the back is added, so now my pieces are sort of whole. Okay, let's add the attribute to this. So I'm gonna say attribute create there. The kind of attribute that I want to add will be on the detail level, so I don't want it to every single point, nor to every single primitive, so I'm gonna go one level up, which is like detail, which you could see it as the entire piece, right? And I'm gonna use the distance function. So if you're wondering about that, just hscript, and I already typed it, xhelp distance, like that, and there you go, there's your distance function. And basically that's the way it works. x1, y1, z1, x2, y2, z2. So we're gonna have to get to our values of our point, our rotating point, and we're gonna get to our values of our individual chunk point, and then it'll just, execute this formula for us. Okay, so the way that I'm going to access the values of my point is using a point expression. So let's start typing. I'm going to bring up an expression editor, and let's start typing distance. Okay, first argument will be x1. So the way to get to that is using point, right? And the sum that I want to get my sort of information from will be my target. Yeah, so there's my target, null target. Then the point number that I want to use is point number 0. I've only got 1 point, so that's easy enough. Then the attribute that I need to use will be p, which is the position attribute, right? And position attribute is vector, so we will access the first component of that vector first, so that will be x, right? And now we're going to copy this another 2 times for the y and the z. And we're going to have to modify it so that the index of the vector is now going to be 1 there, which basically means reference the y value, and once more for the z value. So there, and that's 2, right? Okay, so that's for the first point's value, so x1, y1, z1, and for the second point's value we can use basically the centroid of the point, right? So if I just middle mouse button over my delete, then you can see over there center 2.311 and -1. So basically these values are sort of the center of this piece of geometry, and we can use them. So we will, using $CEX, $CEY, $CZ, right? And now we've got all the arguments for our distance calculation, so you can just say apply, accept, and that should create a distance attribute. We're gonna name it distance, and I'm gonna name it there as well, so I know the name of that attribute. Now before I can straight away use it inside of my poly extrude, I need to be able to, I mean, it gets created, right? I can't just reference it from there. It needs to be cooked. This node needs to be cooked. So what I'm going to do is just create a new null, and let's just call this null distance attribute, right? And what I'm going to do is I'm going to reference the attribute, or sort of get the attribute from this node rather than from that node, so that I know for sure that this node is cooked, right? Let's have a look if the distance attribute is being calculated. So there we go. If you can't see this, right, just change your mode from points or primitives to detail, and there you can see the attribute. Now as I move my time slider, the distance updates, right, as you would expect, because the point is rotating about, right? Okay, so now let's start referencing this. Let's have a look. Okay, so I'm using a little bit of extrusion over there, yeah, something small like 0.3, don't need too much more. So I can bring up my expression editor again and just start typing, plus I'm going to say I'm going to start using my detail, so I'm going to put my distance inside of a fit function, right? And basically manipulate it that way. So the detail, the distance, right, this distance that is stored in detail, I need to access that using the detail function, and that will drive my fit function, right? So let's go get it. So detail, and the one that I want is basically this null distance attribute. So if I start referencing it, so null distance attribute there, that guy. The attribute that I need will be distance, and the component of the attribute is going to be 0 since it's just a scalar. Okay, so that's the first argument, right? So there's my distance. I know it goes somewhere between whatever 0 and something like 4.5 it was, or 5 or something like that. So we could say the first argument goes from 0, and then it goes to maybe something like 2. This is something up to the user. And now we're going to sort of invert that value, right? Because basically what we want is, if the distance is 0, then we want more extrusion, right? If the distance is 2, we want less extrusion. We don't want any extrusion. So we could sort of put in our new minimum, right? So we could say, if the distance is close, yeah, we want extrusion. So we want something small, because I'm using 0.3 already. So something like 0.1, or otherwise just don't do anything. Otherwise just leave it as it is, just 0. Yeah? And let's apply that, and let's see if that's working. So let's go up for a second, and let's see, where is our point? It was a bit small. Well, it is working. I mean, I hope you can, well, maybe you can't see it. So in order to see that a bit better, I'm just gonna get rid of my color for just quickly visualization purposes. Make it a bit more darker, something like, no, something like this. So let's have a look. So from the side point of view, you can kind of see this is a little bit higher. I'm gonna exaggerate it a bit. So in my fit function, now this is where you can start playing around with it. So let's change this number to something like maybe 0.3, so it's twice as high. That should definitely start standing out. Apply, accept. Let's go up. Let's have a look. Okay, now you can really start to see where this point is, and as I start moving it, obviously it has to go through this for loop each time, so you can kind of start to see, it's kind of moving through this geometry, sort of modeling it on the fly. Okay, I'm gonna link that to the inset as well. Actually, I think that it's probably gonna be cool. So this fit function, yeah, let's just say copy that entirely. So minus 0.1 is a good number, so let's use that. Right. So if it's close by, I want this number instead of 0.3. I wanna use something like a minus 0.1. So that'll be using that. And let's apply this, accept it, and let's go up. Okay. So as well as just as you can see there, as well as extruding, it's also doing that inset operation to it. Now you're gonna have to watch out with that inset, because when it gets to the small pieces, yeah, so especially around that area. So let's see when it gets there. Oops. There. Oops. See, especially these very small pieces, these very small things, the inset might give problems if you do it too much. So what you could do, I'm not going to do this time, but what you could do is you could use a measure, yeah, a measure sub, this guy, yeah, and measure the area, right, of every individual primitive, and then put that into the mixture, so that if it's a big primitive, it'll have a bigger inset. If it's a small one, it won't have that much of an effect. So you could do that as well. Okay, so in the next example, what I would like to show is how to, well, before I start rendering, actually, would recommend you to clean this up just like we did there. Just like add this group delete to it, add this color, and then maybe add a null to, like, could just say like that. Let's get rid of that color there, and let's look at it that way. Just want to have that one too, and I'm just gonna call this out, I don't know, distance, something like distance, oh come on, distance pieces, right? So now we can kind of see where that comes from. Okay, in the next example, what I'm going to do is I'm going to still break up the surface and do the extrusion, but do a normal kind of extrusion, and copy every chunk of geometry, every piece, onto particles, and then manipulate the particles with some forces. Very similar as to one of the other tutorials that I've done with sort of jumping tiles.